Hello everyone, my name is HIEW.
And my name is ISMAIL.
This video is about the false position method used in numerical methods. And we'll be doing a question from the textbook Numerical Methods for Engineers, the 7th edition, question 5.7, to explain more about false position method to you. So for question 5.7, this is a question. We have to determine the real root of fx equals to 0.8 minus 0.3x over x. And we have to do it using three methods. The first one being analytical method, and the second one graphically, and the third one using three iterations of the false position method and initial guesses of 1 and 3. And we have to compute the approximate error and the true error after each iteration. And we have to determine, is there a problem with the results? So the first one, analytically. For analytical method, we have to assume that fx equals to 0. And by assuming fx equals to 0, we get a true value of x equals to 2.667. And next, for B, the graphical method. For the graphical method, we just have to substitute different values of x into the equation. And we have done a table of -3 to 3 of x, and we have calculated the value of fx. And therefore, we'll be having a graph which looks like this.
So let's move on into the third question. So as you can see in the third question, we have to do 3 iterations. Now here is the table for filling in all of the values that we'll be obtaining after this. As you can see here is the value for XL for the first iteration, values for XU, FXL and FXU. In order to find the values for FXL and FXU, we have to substitute the values of XL and XU into the equation here, to the main equation. So we'll obtain 0.5 negative 0.033. Next, we need to find the value for midpoint. So, since we have all of the 4 values here, we can substitute in all of these values and find XR. So, we'll get an answer of 2.8751. So, I'll write here 2.8751. Okay. Now, we need to find for approximation error. To find approximation error, we need to have the previous midpoint and also the current midpoint. However, for the first iteration, we don't have any value for the previous midpoint. Therefore, EA is not applicable. Now lastly, we need to find the values for the true error, which is the real root minus the midpoint divided by the real root times 100%. So in this case, the real root that we have obtained from the first part of our solution for this question is that we obtained 2.667. Now we take 2.667 minus by the value of the current which is 2.8751, and we'll be obtaining a percentage of 7.8%. Okay, so let's fill in the tables. So as you can see here, T will be 7.8%. Oops. Oh, I'm sorry. Here's the column for FXR. So FXR is the same as obtaining FXL and FXU. We just need to substitute the value of XR into the main equation here, which is fx equals to 0.8 minus 0.3x over x, and we'll obtain a value of negative 0.0217. Okay, we're done with the first iteration, ladies and gentlemen. Now, before we move on to the second iteration, we have to bear in mind that there is
condition.
Yes, a condition. Thank you, Ihan. There's a condition that we need to remember. So the condition is the function of fxl multiplied by the function of xr needs to be less than 0. Then only we can set xu equals to xr. Okay. Now the value for xl and fxr is, alright, here it is. So this is the value for fxr and fxl, and once we've calculated 0.5 times negative 0.0217, for sure we'll get a negative value, and then for surely we also need to set xu equals to xr. Okay.
But what does setting xu as xr mean? I don't understand, Ismail. Please explain.
Come again, Ian?
What do you mean by setting xu equals to xr? I don't understand, Ismail.
Oh, okay. Now, setting xu into xr means, okay, since we've done with our first iteration, now we need to move into our second iteration. Okay, so in order for us to move into our second iteration, we need to make sure that the values of fxl and fxr from the first iteration is less than 0. Then only we can set the value for the xu in the second iteration equals to the value of xr in the first iteration. Am I clear? Okay.
I see. Please continue.
Okay, thank you, Ihan. Let me wipe off the whiteboard first.
Alright.
Okay, done. So now let's move on into the second part, second iteration. So as you can see, it is the same as the first iteration. However, in this part, we will obtain a value for the previous xr, which is the xr in the first iteration, and we also obtain the xr from the current iteration, which is the second iteration. Then only we can calculate for approximation error. So this is the current value, this is the old value. Okay, let me close. So this is also the current value. So once we calculate, we'll get 2.7886%. So we can write down here ET is equals to 4.878%.
Wait, Ismail, I think it's better that you fill in the table first.
Okay, Ihan. Okay, let me fill in the table so that all of you will be clear. So XL is 1, and then XU is from the previous XR, which is 2.8751, and then for the current XR, we've obtained 2.7971, 2.7971, and for FXL, we obtain 0.5 because there's no changes, and for FCU, we take the value of FXR because XR is the new XU, so it's negative 0.0217. Now for the value of XR, we will follow the same step, which is we substitute XR into the main formula, the main equation, which is this one. So we'll obtain the value for SR, that is negative 0.014, and not to forget the value of EA, which is 2.788.
I see. So that's how you do it. Well, please continue with the final iteration, the third one.
I see you're getting all excited.
Yes, of course. We're finishing it. Let's do it.
Okay. Now you need to remember. That in order for you to move into the third iteration, we still need to follow the same rule just now, which is FXL times FXR. If it's less than 0, we need to set the new XU, which is for the third iteration, equals to the XR in the second iteration.
Oh, but what if fxl times fxr is more than 0? What happens then?
If the condition is more than 0, we need to
I think I remember. I think you need to set XR as XL, right, Ismail?
Yes, you're right there, Lihan. I'm so sorry.
No, it's alright. I remember. Thank you.
Okay.
Let's continue the third
continue with
iteration.
the third and last iteration.
Yes.
Okay. So now that you all understand the rules, we can move on to the third iteration, which is this one. So this is the solution for the third iteration. So ladies and gentlemen, it is the same step again and again, where we calculate the value for XR, find the approximation error, and also we find for the true. Okay, so now let's compute in the table. So we will obtain XL for the iteration, which is 1. SA is the same goes to FXL, which is 0.5. Oops, and value here is 2.7971. It will be 2.7482. For FXU, it will be 0.014, the same as FSR in the second iteration. And for FSR, we need to substitute the value of SR inside the current. We need to substitute the value for the current SR inside our equation. So we will obtain 0.0089. And EA, as calculated here, is 1.78%. And we finally obtain the true error for the third iteration, which will be 3.04%. So, ladies and gentlemen, this is how we solve for the 3 iteration method. So, I hope you enjoyed this video. Thank you very much for your time, and all the best.
Thank you everybody for watching our video. If you have any questions, please leave your questions in the comments. Do not hesitate to ask us any doubts or inquiries you have. Thank you and see you next time.
See you, bye.
Bye bye.